Now let's get started. The first thing you should know about Python is that it's a dynamically typed language. So when we declare a variable like n and set it to 0, we don't have to declare the type at all. So now if we run the code and print n, you can see it's equal to 0. But types are determined at runtime. So we can reassign n to a string now, and that's perfectly fine because n has no type. The type is determined at runtime. So now we can run the code again, and we can see that n was originally a 0, and then it changed to a string ABC. We can also do multiple assignments, but it's a bit different than most languages. If we have two variables, we put them both on the left-hand side, and then we have our equal sign, and then we put the two values on the right side. It's okay to have multiple types in a single line. Incrementing is a bit different. Of course, we can increment a very simple way like this. N is equal to n plus 1. We can also do the shorthand n plus equal to 1, just like most languages, but we can't do plus plus. You can see it even gives us a syntax error. We can't do plus plus. That's related to the Python interpreter, but it's not a big deal. I mean, this is one of the few cases where Python is a bit less concise. Python also has null, but it's called none in Python, which is basically the absence of a value. Unlike most languages, though, we can have a value that's initially a number, or it's supposed to store a number like 4, but then we can reassign it to none, which means null, and then we see it is equal to none. If statements are pretty straightforward in Python, at least conceptually, but syntactically, there's a couple differences, namely that we don't need parentheses. So if we have an if statement like this, we don't need to put the conditional in parentheses, and we don't need curly braces to represent what is the block that corresponds to this conditional. We use indentation for that. So you can see here we have a tab that indicates that this code belongs to this statement. We have a colon that goes after the conditional. Else if works a bit differently. We don't actually have both keywords else if. We even shorten that. I don't really care too much for this, but I'm guessing it just has to do with the Python interpreter because we already have two keywords for if and else. So we have to create a new keyword for else if. At least that's what I'm guessing. While parentheses aren't required for conditionals in Python, they are needed if we have multi-line conditionals. And by the way, logic and in most languages is the double ampersand character, but in Python, it's just the keyword and, or is just the keyword or. So not that this is shorter, but it just makes things a little bit more readable. For example, if we have an if statement that looks like this, we use the keyword and we use the keyword or to mean logic and logic or. And since we have a multi-line conditional like this, these two lines are part of the conditional, we have to put them inside of parentheses. Otherwise, we get a syntax error. Syntactically, while loops are pretty similar. For example, we have a variable n equals 0. We can create a while loop where the condition doesn't have to go in parentheses. The block is followed by a colon and the code itself is indented with a tab. We're printing n, so running the code, we get to print 0 through 4. For loops are pretty similar, so if we want to do the exact same thing, go from 0 through 4, we create a for loop where our variable I is going to go in the range of 5. That basically means it's going to start at 0 and keep going until it reaches 5 and then stop. And I is incremented implicitly. So we don't have to tell this loop to increment I is just going to be incremented on every iteration of the loop by default. So running the code, you'll see we get pretty much the exact same thing, 0 through 4. So 5 is not included as the loop executes. To better illustrate the for loop, let's take a look at another example where we're going from 2 through 5. So in that case, we'd use the same keywords for I in range, but we'd pass in two values into range. We're starting at 2 and we're going up until 6, but not including 6. So now when we print this, we go from 2 all the way up until 5. And if you want to go in reverse, starting at 5 and going down to 2, it would be similar. We'd start at 5, we'd go up until 1, but not including 1, and we'd pass in a -1 as the third argument, because in this case, we're decrementing. If you don't pass in a -1, we increment the I, but when you pass in -1, that means we're decrementing the I. And we actually could have passed in a -2 here as well if we wanted to decrement by 2 every single time, but just decrementing this, going from 5 down to 2, and you can see we get what we expected. I will admit this was one of the annoying things when I first learned Python. Compared to most languages where you can do something like this, explicitly declare the variable, explicitly state the condition, and explicitly increment or decrement, this Python syntax is definitely a bit trickier, but I think as you get used to it, it's easier to type out than this bottom stuff that I have here. Division is also a bit tricky in Python. It's decimal division by default, whereas most languages use integer division. So 5 divided by 2 will actually give us 2.5, whereas in most languages, it'll round towards 0 by default. If you want integer division, you have to use double slash like this. So printing this will actually round down. You can see we get 2 as the result. But if you caught what I just said, you have to be careful because most languages will round towards 0 by default. But in Python, if we do integer division, we're rounding down. So you can see -3 divided by 2 will actually round down to be -2, where the decimal value would be -1.5. In most languages, it would be -1. A workaround for this is to use decimal division, but then convert the result to an integer. Because when you convert to an integer, it will round towards 0. This is kind of annoying, but it's just something you have to do. You can see running this will give us a -1, which is what you might want in certain cases. Though I'll mention it's pretty rare to have to need to know this, I'm just mentioning it in case you run into any issues. Using the modulo operator is pretty similar to most languages, so 10 divided by 3, getting the remainder, we would expect a 1, and that's exactly what we get. Except the issue is, once again, with negative values. Just like dividing negative values, when we mod negative values, we get unexpected results. And -10 modded by 3, well, the answer is actually 2. And this is different from most C-based languages like Java, C++, I think even JavaScript. So if you want to be consistent with those other languages, you can import math and then do fmods. Using this will give us -1, which is what you might have expected. A few more useful math helpers. We have floor, which will explicitly round down. We can also do the opposite, which is the ceiling. So 3 divided by 2 rounding up. If you need to take the square root, there's a helper. And if you need to take the power of a variable raised to another, so 2 to the power of 3 would be this. If you ever need a maximum integer, you can use float infinity. And if you ever need a minimum integer, you can use float -infinity. And part of the reason that they come up is because Python numbers are infinite, so they actually never overflow. So if we have a number like this, 2 to the power of 200, which is a very large number, as you can see on the right after we print it, it's so large that we can't even print it. It's 60 additional digits. But even this large integer is still less than infinity. Checking if this number is less than infinity, we get true. Arrays, which are called lists in Python, are probably the most common data structure you're going to use next to hash maps. So an array can be declared just like this, but initializing it is pretty straightforward. You just put the values inside of some brackets, and printing it is just as simple. Arrays in Python are dynamic arrays by default. So just like in most languages, dynamic arrays can be used as stacks. So you can push to the array, aka append, and you can also pop from the array, which will pop from the end, of course. So after we push a 4 and we push a 5, we can print that. And then after we pop the last value, you can see that we popped the 5. Because this is technically an array and not a stack, we can actually insert into the middle. So at index 1, we can insert a value 7. Printing that, you can see we indeed inserted a 7 into the middle of the array. But unlike pushing and popping from an array, inserting into the middle is a big O of n time operation. But it's not a big O of n time operation to index an array. So at index 0, we can read the value and we can also reassign the value to 0 in this case, and we can reassign the value at index 3. And these operations are constant time operations. To initialize an array of variable size, let's say we wanted an array of size 5 and we wanted all values to be 1, we could do it pretty easily. It might be kind of weird to use the multiplication operator here, but syntactically it's pretty easy. Printing the array and the length of the array, you can see we do get what we expect. But be careful when indexing an array, especially when you're using negative values, because -1 is actually not out of bounds in Python. -1 will actually read the last value, as you can see on the right. And to read the second to last value, you can use -2. Now, in my opinion, this isn't super useful, but sometimes it can be when you want to quickly read the last value. Getting sublists, aka slicing an array, is one of the most useful features of Python. So here we're taking the values of the array from index 1 to index 3, but not including index 3, just like with for loops, and then printing those values. So we would expect 2 and 3, and that's what we get. And we could also go from index 0 to 4, which is pretty much the entire array, and that's valid as well. Unpacking is also a super useful feature. Basically, we can take all the individual elements of an array and assign them to variables, in this case A, B, C. This can be super helpful when you want to go through a list of pairs, for example. Be careful though, because you do have to make sure that the number of variables on the left-hand side does match the number that you're expecting from the array. We can loop through arrays in many different ways. Using the simple for loop syntax we talked about earlier, we can take the length of the array and then iterate that many times using an index I and then printing the individual value. An easier way to accomplish the exact same thing is without using an index. So we can actually go through every value in nums and then just print that individual value. If for some reason you needed both the index and the value, you could use the first for loop I have shown up here, but another way to do it is to use the enumerate function in Python. So enumerate will actually give you the index, which will be the first value that's unpacked, and the second value that's unpacked will be the number, and then we can print both of those if for some reason we needed both of them. And all three of these loops execute as you would expect. Now, if we want to iterate through multiple arrays simultaneously, we can do that with unpacking and a helper function called zip. Zip will basically take both of these arrays and combine them into an array of pairs, and then we can unpack those pair of values, which are values from nums1 and nums2. We get pretty much what we expect. Reversing an array is as simple as calling the reverse method on that array. So 1, 2, 3 becomes 3, 2, 1. Sorting an array is just as easy. Taking this array, we can call sort on it. So this will sort it in ascending order by default. If we want to sort it in reverse order, we just pass in the parameter reverse equals true, and then the array will be sorted in descending order. We can also sort a list of strings. By default, they will be sorted based on alphabetical order, as you can see on the right. But if we want to implement a custom sort, for example, if we want to sort based on the length of each string, then we can do that by passing in a lambda function. So in this case, the key is equal to lambda, which is basically a function without a name, and we're going to take every single value from the array, call it x, and then return from that the length of x, and this is the key that's going to be used to sort the string. So each string is going to be mapped to its length, and then we're going to sort those strings based on their length. So by default, it's going to be in ascending order, as we can confirm on the right. Another sort of advanced way to initialize lists is using list comprehension. So if we wanted to go through every value in range 5 and call that value I, and we want to add that value to this array, this is the shorthand. So we're iterating for I in range 5, and then I is going here. So we're taking that I value and adding it to the array, and printing it, you can see that we indeed have 0 through 4. Now maybe we want to go through every value in that range, but we want to take I and add I plus I to the result. So for every index, we want 2 times that index added to the result. You can see we can also do that pretty easily. If you want to do something similar for a 2D list, it's also pretty easy, but maybe a bit different than you would expect. The easiest way to do it is the shorthand that we talked about earlier, where we take an array with 0 and then multiply it by 4. This will give us an array of size 4 with all zeros. And we want this array to be added to the outer array 4 times. So we have an inner loop for I in range 4. We're not even using the variable I here, but this will build a 4x4 grid of all zeros. You might be thinking, isn't there an easier way to do that? Well, actually not. You might be thinking, can we just do this, create an array of size 4 and then multiply that by 4? Well, technically this will work, but each of the 4 rows of this array are going to be the same. So if we modify one of the rows, we're going to be modifying all of the other rows. We're not actually creating 4 unique rows in this case. It's a common thing that can throw people off. If you have more questions about this, feel free to ask in the comments. It's something that tripped me up a lot when I first started. Strings are pretty similar to arrays, so we can declare one with double quotes. You can also use single quotes if you want, and we can slice them the same way we do with arrays, and printing it works the same. But a key point is that they are immutable. That means we can't modify the string. That means we can't reassign the character at index 0. We can, however, update the string, but updating it will actually create a new string. So adding def to the end of the string will create a new string. So basically, anytime you modify a string, it's considered an end time operation. Strings can be converted into integers, and then those integers can be added. Integers can also be converted into strings, and then those strings can be added together. So when you add 2 integers together, we get an integer as the result. Adding 2 strings together appends those strings together. So we get 1, 2, 3, 1, 2, 3. If for some reason you need the ASCII value of a character, you can do that with the OR function. So printing this, you can see we get 97 is the ASCII value of lowercase a, 98 is the ASCII value of lowercase b. You can also join a list of strings together with a delimiter. In this example, we have 3 strings and we're joining them with the empty string delimiter here. So we're basically just appending these 3 strings together. We could also have had a delimiter, maybe a space in between all of them, and printing the result, we get all 3 strings appended. Queues in Python are double-ended queues by default. You can import them. Adding values to the right side is as easy as appending to the queue. So at this point, our queue isn't much different from a stack, but the benefit is that we can actually pop from the left of the queue, and we can do this operation in constant time, unlike with a stack, as you can confirm on the right. Since it's double-ended, we can also add values to the left of the queue. So the one that we popped, we can add back to the left side. And also we can choose to pop from the right side if we want to. So running this, we can confirm that the 1 is added back, and then we pop the 2 after that. Hash sets are really useful because we can search them in constant time, and we can insert values also in constant time. Of course, there won't be any duplicates in our set. Of course, unlike a list, there can't be any duplicates in a hash set. But we can just as easily get the length of the hash set to know how many elements have been inserted. We can also search the hash set without a function. We can use the in operator. So if we want to know if 1 exists in the hash set, same thing with 2, same thing with 3, which we know does not exist in the hash set, as we can confirm. We can remove values also in constant time and confirm that the value has indeed been removed. To initialize a hash set with a bunch of values, we can actually pass in a list. But just like with lists, we can also do set comprehension and manually initialize it with a loop inside of the hash set. So here we're going through every value in the range of I and taking that value I, adding it to the hash set, and initializing it this way is identical. Hash maps are probably the single most common data structure you're going to be used, and this is what we were saving those curly braces for. To insert, we simply take some key value, in this case a string, and assign it to another value, in this case a number 88. And we can add a bunch more. Just like with hash sets, we can't have duplicate keys inside of the hash map. Printing it is just as simple. Taking the length will give us the number of keys that exist in our hash map. We can modify the value that's mapped to a key, so we can change Alice from being 88 to 80. We can also search if a key exists in a hash map in constant time, and we can also remove that key, which will also remove the value, as we can confirm on the right. To initialize a hash map, we can add pairs inside of the curly braces, where each pair is separated by a comma, and the key goes on the left side of the colon, and the value goes on the right side. This is the same as manually inserting values into the hash map. But if you want to get even more fancy, you can use dict comprehension. Hash maps are basically called dictionaries in Python, and the syntax is pretty similar, but in this case, if we're looping I in the range of 3, we're going to have 2 values. I, in this case, is the key, then a colon, and then the value goes after that. In this case, we're mapping I to 2 times I. This is pretty powerful, and I find that I use it most frequently when I'm doing graph problems and trying to build like an adjacency list. Looping through a map is pretty interesting because there's many ways to do it. By default, we iterate through every single key, and then we can, print that key and also print the value that that key maps to. But also, we can directly iterate through the list of values of that hash map if we don't even need the key. Lastly, using unpacking, we can actually go through the items of that map, which will give us the key and the value. This is pretty similar to the first loop that we have. I guess it's a bit more concise to write it this way. Python also has tuples, which are pretty similar to arrays, except to initialize them, we use parentheses rather than brackets, and they are immutable. So while we can index them, we can't modify them, so this won't work. You'll mainly be using tuples as keys for a hash map or a hash set. So in this case, we're mapping a pair of values 1, 2 to 3. So this tuple is basically our hashable key. We can do the same thing for hash sets, of course. And then we can use that tuple to search the hash set. The reason we do this is because lists are not hashable and can't be keys for hash sets or hash maps. So this here will not work. Heaps are another really common data structure to find the min and max of a set of values frequently. Under the hood in Python, they're implemented with arrays, of course. So actually to create an empty heap, we just create an empty list. And to push values to that heap, we use heapq.heapPush to that min heap, the value 3. By default, heaps in Python are min heaps. So we push a few more values, and then to get the minimum value, it'll always be at index 0. That's just how heaps are implemented. To loop through a heap while the length of the heap is non-zero, we can also pop values from the heap with heapq.heapPop from that min heap, and then print the corresponding value that we just popped. Since it's a min heap, we'll see the values are printed from smallest to largest. While Python doesn't have max heaps by default, the workaround is basically to multiply each value that we push by -1, and then after we pop that value, we also multiply it by -1 to negate the original -1. So if we wanted to implement a max heap and push the value 3, we would actually push -3, and if we wanted to push 2, we'd push -2, same thing with 4. Again, the max will always be at index 0, but we know we have to multiply it by -1 to negate the original -1. By popping each value and multiplying it by -1, we can confirm that the values are printed from greatest to smallest. Now, if you already have the initial set of values that you want to build the heap from, you can do it in linear time by calling build heap, or in Python, it's called heapify. So we can call heapq.heapify this array. And while that array is non-empty, we're going to keep printing the values, and we can confirm that they're printed from smallest to largest. Functions in Python are pretty straightforward and concise. We use the def keyword, we name the function, and then we pass in some parameters, in this case n and m. Just like with conditionals and loops, we use a colon after the declaration of the function, and the body of the function is going to be indented. So we're returning the multiplication of those two values and printing the result. One functionality I use a lot in coding interviews is nested functions. This can be really helpful in recursive problems because if you have an outer function that takes in a couple of parameters and you also declare some values in that outer function, the inner function will actually have access to all of those variables by default. So then if we called the inner function, we don't even have to pass in a, b, and c. Now this is a pretty simple example, but if you've watched any of my graph videos, you know how nice this can be in keeping our code concise. One thing that trips a lot of people up with nested functions is that you can modify objects, but you can't reassign values unless you use the non-local keyword. So if we have a function that's going to double every value inside of an array and also double this value itself, this is not an array, we can have a helper function. It'll have access to both of those outer variables. We can modify the array pretty easily by going through each value in the array and then doubling it. This works and will update the original array. But if we double the value, it'll only double the value in the scope of the helper function. If you want to update the value outside of the helper scope, you'll have to declare it as a non-local value, and doing this and then modifying the value will modify the original values. And then in the outer function, we can call the helper function without passing in the variables and then print the variables. Now to actually call the double function, we can create some variables, call it, run the code, and we can see that each variable was doubled. Again, this is a trivial example, but if you're familiar with my videos, you know that this can be helpful. Classes are also pretty concise, but a bit more limited than other languages. A constructor is basically double underscore init, double underscore after that. That's kind of the name of the constructor in Python. Self is passed into every method of a class. It's basically like the this keyword in other languages. In this case, our constructor is maybe taking a list of numbers. To create member variables, we also use the self keyword. So this is creating a member variable called nums and assigning it to the nums that were passed in as a parameter to the constructor. We can also create a member variable for the size of nums, by taking the length of the parameter. To create a method for this class, for example, getLength, we don't want to pass in any parameters to this, but we have to pass in the self keyword always. That'll give us access to our member variable, which we're going to return self.size. If we want to call another member variable from a member variable, in this case, we want to call getLength from this other function, getDoubleLength, we can do that again with the self keyword. This is a pretty useless example, but I'm mainly trying to explain the syntax and the structure of classes in Python. Now, this is more or less everything I've needed to know for coding interviews. It's surprisingly not a lot. And you don't have to memorize any of this. As you solve coding problems and as you prepare for interviews, you might have to look up the syntax or how exactly do I use heaps? How exactly do you use double-ended queues? Things like that. It's perfectly okay. But after you practice enough, most of this stuff is pretty easy to get down. It doesn't even feel like you're writing code after a while. Python is a pretty big reason I was able to get a job at Google, in my opinion. Now, if you're preparing for coding interviews, check out neetcode.io. There's a ton of free resources to help you prepare. Each practice problem listed has a thorough video explanation, and we have code support for Python, C++, Java, and JavaScript. If you're new to data structures and algorithms, I've got some really helpful courses, not only for beginners, but also for advanced users. Thank you so much for watching, and hopefully I'll see you pretty soon.